Good morning, everyone, and thank you very much for joining our webinar. And it's our pleasure to present our activities within the Competence Centre. And here I'm together with my two colleagues. So I'm Valentin, and with my colleagues Elnas and Jaime from Karlsruhe Institute of Technology. The outline, my control is, here. So the outline, we shortly present the Competence Centre, who constitute the Competence Centre, and then Elnas will talk about, about one of the achievements or outcomes of the Competence Centre activity, best practices for image analysis, and then Jaime will present yellow model, which we have as a generic module on the iMagine platform, how to use it, how to profit from it. So the Competence Centre, the main mission is to facilitate the path from image data, which are produced by scientists in aquatic sciences, to imaging applications and services. The methodology which we apply is we definitely connect experts from different domains. That's not only scientists who develop these applications, but we need different type of expertise. We stimulate the knowledge exchange between all the parties. We have to speak the common language because, scientists are very well educated in their domain, but we may use different words for the same thing when we talk about computing science. So we have to find the common language and understanding. Then, of course, we provide training and support through different means and in different aspects concerning every stage in the machine learning cycle, life cycle, but also fairness, the platform itself, and service management. And based on all these interactions, we create best practices. So that's a bit to, again, show how the Competence Centre, what are the components of the Competence Centre we have in the project itself, which is often divided into work packages. So we have domain scientists and AI experts. In the end, these are domain scientists who develop their applications and do programming. And they also have already some AI expertise, but we also have AI expertise, and altogether we find what is the best way. We also need IT experts on how to use the platform, how to do deployments, how to do the continuous integration and development, for example. And as Ilaria already mentioned, the platform itself is based on the software stack, which is called AI for Open Science, or in short, AI for OS. And that has been developed in the sister project, AI for EOSC, European Open Science Cloud. And especially that some of us also work in this project, we have a very good connection between the two projects. And this is a synergetic approach where then we have many use cases who have their interest and provide us with requirements and feedback, which is very valuable input for the AI4S developers. And we also get, as I imagine, all the fresh updates of the software and the platform. So to show you a bit in more details the diversity of the use cases with whom we started from the beginning of the project, we have, for example, aquatic litter drones where people use drones to monitor the litter pollution in different areas. We have taxonomic identification of zooplankton using ZooScan device. We have 3 participants from the EMSO ERIC sites, marine ecosystem monitoring with underwater imagery, video imagery from cameras, underwater cameras in Spain, France, and Ireland. We also have people who want to control oil spill detection or use satellite images to detect oil spills, and flow-count phytoplankton identification from Belgium. These 5 cases, they already had images, they already had some means how to process these images, and they wanted to improve their means with the AI, and they want to create finally services for their end users. So we call them major use cases. And then we have 3 other cases who had already images, but they were only starting the analysis of these images. And then during the course of the project, they developed applications. And here we talk about beach monitoring on Mallorca in Spain, underwater noise identification also from Belgium, and freshwater diatoms identification. These are iMagine, the project use cases, who, as I said already, and Larry also said that, started together with us from the beginning of the project. And then once we learned certain requirements and improved also the platform according to these requirements from our iMagine use cases, we also started to onboard the external use cases by organizing open calls. The open calls now ended last month in February because, again, as Ilaria said, the project runs until August this year. So, of course, if any new use case comes, they need time to implement. And since we end in August, we stopped onboarding new use cases last month. But before last month, we got last year these 4 use cases again with different variety in aquatic sciences, like improving knowledge about cold water coral reefs, people developing satellite-derived bathymetry, using AI for image-based age reading from fish otoliths, and then validating images collected with the Iron on Water app, where pretty much everyone who downloads this app can contribute to the knowledge about quality of water by making photos from the smartphone. And this year we got 2 more use cases, the decentralized learning use case, which is more even another project where they have a few participants, but we communicate with people from PML in UK, and they also use plankton images, also including the FlowCam device as one of our use cases, major use cases, but they want to use decentralized learning so for that different parties can contribute in the decentralized learning way to train the AI model. And then the last case is sea wave and coastal inundation detection methodology from Portugal. So that's a big variety of the scientific cases which we deal with. And again, to stimulate the knowledge exchange, we organize regular meetings with iMagine and open call use cases bi-weekly and monthly. We try to understand all the parties that we speak, as I said, the same language. We provide the generic modules ourselves, so we ourselves produce also examples for use cases. We talk with them. We also assist them sometimes with their data sets, so to better understand what they need and what we can provide. And that's, for example, resulted in one of the generic models, which Faima will present in yellow with the yellow model. And then we do training and support using Competence Centre workshops. They are annual, so the last one in 2025 will happen in 2 weeks. We organize dedicated events and various conferences, webinars, which Ilaria already mentioned, and like the one which is ongoing now. As we have good connection with the AI for IOSC, we also join their workshop and their webinars. Then EGI is the coordinator of the project, organizes FITSM course for image service providers. This is a service management in a light way. And of course, we have various email lists to support use cases, individual meetings, and consultancy. And all this experience we summarize in documentation, deliverables, data sets, and best practices, which will be presented next by Elnas. So summing up, we pretty much get use cases who know how to collect raw data of various type images, and then we assist them with every stage of the machine learning cycle that in the end they produce either application or services which are shared on the marketplace of their project. They can serve them through the inference platform. They publish their training data sets on the Zenodo, and all these experiences we also summarize in best practices. And that this is the current view of the marketplace, and that is ended up in the number of applications from the use cases, which you see here in green, image use case modules, the generic modules, which we also developed, and also external use cases contributed. And as Larry already announced, The major use cases now provide their services to their end users, and you can request access to this on our website, which you can find here. And with that, I pass the floor to Elnas to present best practices. Thank you.
Yeah, thanks, Valentin, for introducing the Competence Center. And hi, everybody. As Valentin mentioned, we have learned lessons from the 8 mature use cases, mature and prototype use cases during their whole AI developments, from data labeling to delivering the AI model to the community. We have published these achievements in October last year as best practices for producers and providers of image sets and image analysis in aquatic sciences on Zenodo repository, which is available under the link that you see here on the slide. And until now, we have about 200 downloads of this document. So see if I can change the slides. Now. Yep. To give you an overview of this document, these are the covered topics starting from suitable deep learning models and annotation tools for labeling training datasets to open source data repositories, performance monitoring tools, and model delivery approaches. As you see here in this diagram, also Valentin mentioned, we covered the best practices for all the steps of this machine learning development cycle. That I will give you some more details about this document in the next slides. So, as you know, the effectiveness of image processing models depends on the quality and quantity of the annotated training data. Therefore, we discussed several annotation tools used in aquatic science and image processing applications. For example, Label Studio is complicated to use and install locally. Beagle is a web-based open source tool developed for marine domain and is used for image and video annotation. Or RoboFlow is a cloud-based platform. Labelbox is customizable for different data types. Among all these tools, CWAT is the most commonly used and user-friendly, which has a user-friendly interface and it has robust annotation features, which is also integrated in the iMagine dashboard and is ready to use. You can click on the QR code here and see how to use it. So, sharing these valuable labeled data sets helps to expand scientific knowledge and simplifies the collaboration among scientists. And that's why we used also Zenodo for this. Zenodo is one of the robust publicly available repositories to store, manage, and versionize open data sets. iMagine use cases created and stored their training data sets at iMagine Zenodo community, which you can also access from the link here. Zenodo serves as a general repository. Therefore, iMagine and Zenodo agreed to extend the metadata format for aquatic science domain. The datasets which already uses a common template will be also migrated to domain-specific metadata format. Yeah. Also understanding data biases and ensuring fairness in aquatic science models is important for reliability of the predictions they provide. The best practices document, in the best practice document, we give recommendations about handling imbalanced data sets. Also recommendations about which tools you can use. Fair EVA tool, which is also integrated in the iMagine platform, measures the current fairness level of the data sets stored on repositories and guides the researchers to improve fairness compliance. And till now, I talked mostly about the data and labels. So if I go to the next slides, I think it's a bit slow. Yeah. Now in the diagram, we are in the creating, updating models, training, and testing the data sets. After preparing our data, we need to select a proper deep learning model based on our tasks and requirements. For classification purpose, MobileNet is one of the examples, which is good in classification tasks. Or for object detection and segmentation, YOLO is the commonly used and performant model. And for segmentation tasks, we saw that Mask2Former showed better performance than Mask RCNN in our use cases. The whole training and testing phases can be done in iMagine Marketplace. And for the evaluation phase, you see here also in the diagram, we have evaluation methods and performance metrics, which help us to access the model's performance for the intended tasks. Here you see some common metrics such as accuracy, precision, F1 score, and intersection of union, which are the mostly used metrics from iMagine use cases to evaluate the models. Yeah. And experiment tracking tools. So we are in the phase of monitoring the models. Experiment tracking tools allow us to organize, record, visualize, and analyze experimental data. These tools make it easier to compare different training processes and hyperparameter tuning. For this, there are various tools like TensorBoard, which has a few functionality. It's a single user and self-hosted tool. Weights and Biases, which is a cloud-based service. And finally, MLflow, which is one of the efficient tracking tools, which is also integrated in the iMagine platform. And you see here a screenshot of the tool. It is one of the practical tools for our users. Yep. And once the AI model is trained and validated, it can be shared on the iMagine Marketplace and deployed as aquatic image processing service. You see here we are in the serving model phase, and we also upload our models on the data repositories like GitHub, and AI models are published as Docker images and code repositories. Anyone who is authenticated can use a try button on the marketplace and try the model's inference for 10 minutes. And for model deployment for inference, we use Oscar, which offers a serverless and scalable deployment for users. So with that, I give the floor to Fahima to talk about YOLO model.
Hi, thanks, Carlos. Okay, I have the control. Here, in a very quick demo, I want to show you how to use Yellow V8 in iMagine platform. You only look once, or Yellow is real-time object detection using CNN algorithm. This model, unlike model like RCNN, this model process entire image in one pass for speed and efficiency. Through the years, a different version of this model was developed, and right now, I think the version 12 is available and is possible to use for object detection. Ultralights is a company that develops computer visions, and they are known for packaging and maintaining the yellow model. Yellow from Ultralights can perform classification task. That means identifying what object is in an image. Object detection, which is detecting and localizing multiple objects in an image, and segmentation, which is identifying the exact shape and boundary of the object in an image. Now, let's go to the iMagine dashboard. In iMagine dashboard, if in the marketplace, if we scroll down, we can find this yellow V8 model, which we use this yellow V8 from Autolattice, and we add DPass API to it. If, as Ella's already mentioned, in the right side, we have three buttons. One of them is this try button that everyone can authenticate themselves with one account in the dashboard, and they can use this try button. This try button create a 10 minutes, a short 10 minutes deployment for using Gradio interface to see how the inference of yellow works. Yeah, this is the Gradio interface that I get for the Yellow V8 model, and this Yellow V8 support different output like JSON, PDF, image, or MP4. Here I try MP4. I upload my image. There are different parameters that you can play with or change them, but I keep them as default and submit my request to get hopefully to get the output for this image. Yeah, this is the output for the detection. I can also change the task to the segmentation, and then I get the output for the segmentation task. There are two other buttons that is only available for the use cases of the iMagine project. For example, this code space, when a use case has their own data set and they want to train this yellow V8, they can use this code space button. They can create a deployment from this yellow V8. Since we want to train the model, we ask for the Jupyter Lab. Then in the next page, user can configure the hardware. They can ask for the GPU. Since it's the training, we ask for GPU. They can specify GPU model they want, or they can increase the RAM memory and disk memory. The next page is for configuring the storage. In the project, we provide an instance of Nextcloud as a storage to our use cases. Here they can configure the Nextcloud credential here, and then from their deployment, they have access to the Nextcloud. In this section, the user can add one data set from Zenodo or from supported DOI. For example, here I choose one of the data set from one of use cases of iMagine project, and I add it to my deployment. When I submit my deployment, I can have access to this data set from my, it will be downloaded on my Nextcloud account, and I can have access from my deployment. When the status of the deployment change to running like this one, I can click on the info button. Then I can see that this ID button is active, and I can click on it and get access to the Jupyter Lab. Here we have all the code necessary for training Yellow V8, and all the package are already installed. The first thing I recommend to you is to read the README, because here you can find how you can, for example, track your experiment with MLflow, or how you should prepare your data set for different tasks. As I mentioned, from my deployment, I have access to my Nextcloud account. I just need to go to this storage directory, and from there, I can see all the data that I have on my Nextcloud. The data set that I downloaded during creating this deployment will be saved in this AI for OS storage. To train the model, I just need to start the DPass API, then go again to the dashboard, click on the info, and here I can see this API button is activate. This API button redirect me to the Swagger interface. In the Swagger interface, we have different parts. For example, metadata. From metadata, I can get all the metadata related to this Yellow V8 module. And for the training, I need to go to the training section, click on try it out. Here I can choose between different tasks. I choose detection. I can choose between different version of the Yellow V8. And for dataset, I will use one of the dataset that I have on the Nextcloud. There are other hyperparameters for Yellow V8 that you can easily change here. But one of the most important one is this enable MLflow, that if you change it to true, then you can and execute the training, then you can log your experiment in the MLflow. If I look at the terminal, I can see that my training is started. In the iMagine project, as Elna's already mentioned, we provide an instance of MLflow to our use cases. For our use cases, they just need to go to this sign up page of this instance and log in with their AGI checking. Then the username will be the email that they use for AGI check-in, and they can choose a password here. After that, they can use this username and password to log their experiments in the MLflow. I already logged some experiment for this Yellow V8 object detection here. Let's see what we logged during the training. During the training, as you can see, we log all the hyperparameters that you choose in this Swagger interface. We log the model metrics during the training. We also log the system metric, and we also log the weights of the model, trained model. In the MLflow, you can also compare different runs with each other. For example, I want to compare these 3 runs, and I can choose, I just want to see the different parameter, what was the difference between my parameter in the 3 runs, and then why it doesn't work. And then check the metric during the training. Then based on the metric, I can choose which runs I had the better performance model, and then go to that, for example, this one, that go to that run and register my model in the model registry of the MLflow. Then if I go to this model registry, I have 25 version of this training model, and my version 20, I put the version 20 as a production because it has the better performance compared to other version. but you can also change. If you have a better performance model, you can change this production to that one. If we go back to the marketplace again and click on this yellow V8 module, we have this deploy button. Here user can use cases can create their inference service. As Elna's already mentioned, we have this Oscar cluster, or they can use the resources from the dashboard again for the inference, or since all the models on the marketplace are Dockerized, they can use their own cloud resources. Here I can use the resources from the dashboard and create, since it's just inference, I don't ask for Jupyter. I keep all the things as default and submit my deployment. When my deployment is running like this, if I click on info, I can see that I have two buttons activate. One of them is API, which again redirect me to the Swagger interface. In the last part, I have the last section, I have this prediction section, which is exactly the same as Gradio interface that I already shown you. You can upload an image and then execute the prediction. Here I ask for the JSON output, so I have this JSON output with the name of the object and the bounding box coordinate. You can also see this user interface, which is exactly the Gradio interface that I have already shown. So the last thing that I wanted to mention is that some of use cases of the iMagine project use this generic yellow V8 model, and they train this model on their data set. For example, these two modules from SmartPy, or this one from OPSI fish detection. They use this existing module, yellow V8 module, and they train the yellow V8 on the video from underwater to detect fish. I think that was all I wanted to mention. Yeah. And this is a summary of our talk. I think, Valentin, you want to talk about the summary.
Well, so yeah, concluding maybe what you sort of an entry point for the project is a marketplace where you find all the applications with quite a rich metadata, and maybe to support this fairness and openness of what we are doing, every application you find there is open source, and you can find the corresponding GitHub repository, and also every application is Dockerized, which means that you can try it also principle almost wherever you can, wherever you have resources, your laptop or cloud resources, or also HPC is possible with the container tools like UDocker or Singularity. And so we also provide some other types of metadata, like on what data set it was trained, and those trained data sets are published on Zenodo in the iMagine community. And just summing up that really the Competence Center activity is to support users, use cases, scientists in developing their applications and services, starting from the raw data to final application or service. And that, yeah, concerns all the steps and aspects of that process. And thank you for your attention and joining this webinar.